this video, we are going to explore what is meant by Faraday rotation. This is one of the reasons why we are preferring the circular polarized antennas for satellite communication. So consider the case of the satellite communication. We have an antenna on the Earth and we have the satellite. So for the communication to happen, there is the wave propagation happening in between these two antennas. So when the wave propagation happens, it has to go through the atmosphere. So one of the layer of the atmosphere is the ionosphere. So this ionosphere is the Earth where Earth atmosphere meets the space. This ionosphere stretches from around 50 to 400 miles above Earth's surface, and uh, in this upper atmosphere, the ionosphere forms the boundary between Earth's lower surface where we live and breathe and the vacuum of the space. So in this area, the particles are ionized by the sun's energy. So this is like a ionized state of the Earth's atmosphere. So when the wave propagates through the atmosphere, phenomenon called Faraday's rotation happens. So let's see what is meant by Faraday rotation. So we know that every wave has a polarization like linear polarization, circular polarization, or elliptical polarization depending upon the orientation of the electric field. So the rotation of the plane of the polarization of an electromagnetic wave as it passes through the region of free electrons, that is in our case the ionosphere, and the magnetic field which is caused by the Earth's magnetic field is called Faraday rotation. So the reason for Faraday rotation in our satellite communication case is as because of the ionosphere and the Earth's magnetic field. So when this polarization rotation happens, it can cause signal fading. You can imagine that if you are using a horizontally polarized wave and due to the Faraday's rotation, it is causing the polarization rotation, and a vertically polarized wave is received, it can cause signal fading and polarization mismatch and communication error. So this is one of the unwanted reason in our satellite communication. That's why we are always preferring the circular polarized antennas for the satellite communication. So the amount of rotation provided in ionosphere is given by the expression Rm into lambda square. So this Faraday's rotation is wavelength or frequency dependent. So you can see that the rotation caused is directly proportional to the wavelength. So as the wavelength increases, the Faraday's rotations will be more. That means that at lower frequencies, because wavelength and frequencies are inversely proportional. So at lower frequencies, this Faraday's rotation will have higher predominant effects. And this Rm is known as the rotation measure. So it is given by this expression, and it depends upon the electron density in that ionosphere and the length of the path it has to travel from the Earth antenna to the satellite and the projection of the magnetic field. So this is the Earth magnetic field. So everything is depending upon this Rm. So this Faraday's rotation depends on the wavelength of the operations and the rotation measures. Let's see why the polarization rotation happens when it is passing through the ionosphere. So we know that in ionosphere we have like electrons due to the ionization of the atmosphere from the sun's energy. So we have electrons in the ionosphere and we have Earth's magnetic field. So we have the magnetic field from the Earth and the electrons. So these electrons will be interacting with the Earth's magnetic field and it will be rotating around this Earth magnetic field. So when we have a right hand or left hand circularly polarized wave propagating through this ionosphere, it will interact with these electrons. So based on the orientation of the magnetic field of this right hand or left hand polarized wave, it will cause different velocity to the propagation, because we know that the orientation of the magnetic field will be different for right hand polarized wave and left hand polarized wave. So because of that orientation of the magnetic field and Earth's magnetic field interactions, they will experience different phase velocity and they will uh, move in the atmosphere with different speeds. Because of these interactions, it can cause some phase variations. That is how the polarization rotation is happening. So the this phenomena where it is causing different velocity or they are experiencing slightly different refractive index is known as circular Birefringence. So as it is happening, the polarization rotation is happening. So when we consider the case of a linear polarized wave can be considered as a combination of right-hand circularly polarized wave and left-hand circularly polarized wave. So here you can see that if this is the linearly polarized wave, this can be uh, get from right-hand circularly polarized wave and left-hand circularly polarized wave by the addition of these two wave components. So in case of a linear polarized wave, when it pass through the atmosphere, that is through the ionosphere, the interaction with the ionosphere will cause some rotation for this wave. So if a horizontally polarized wave is passing through the ionosphere, based on the interaction, it can cause the rotation of the polarization. So sometimes the polarization rotation may not be perfect, like a horizontally polarized wave will be converting into the vertically polarized wave, something like that. But sometimes it will be causing some polarization shift, not like the perfect conversion from horizontal to vertical, but it is like slightly changing to the slanting polarization or some sort of shift to the polarization. So this is known as the Faraday's rotation. So the main reason for the Faraday's rotation is the ionized atmosphere and the Earth's magnetic field. So if you are using a circular polarized antenna, this it can accept even linearly polarized wave with 3 dB loss. That's why we are always preferring circular polarized antennas for our satellite communication. I hope you get some idea about what is meant by Faraday's rotation. If you find these videos are useful, kindly support by liking, commenting, sharing, and subscribing. Thank you.